Hello everyone, welcome to my channel once again. So today we will be solving this problem, lead code number 66 plus 1. Let us understand what the problem description is. Okay, so you are given a large integer represented as an integer array digits. This is the name of the array digits, where each digits I is the ith digit of the integer. The digits are ordered from the most significant to least significant in left to right order. The large integer does not contain any leading zeros, and we have to increment the large integer by 1 and return the resulting array of digits. For example, see, this is the name of the array digits, and 1 is the most significant digit, 3 is the least significant digits. We have to add 1. So, as we have done in our junior classes in the school, how did we were adding? We were adding to the LSB, starting from the LSB. Since we have to add not the LSB, least significant digit. This is not a bit, this is a digit. Okay. So least significant digit will be starting and adding. So plus one will do here. It is 1, 2, 3 plus one will be 1, 2, 4. Okay, so this is the output. Here 4, 3, 2, 1 plus 1 will be 4322, and 9 plus 1 will be 10. So this is the case. So first I will discuss the brute force approach, then we'll move on to the optimal solution. So brute force solution is what? Like we have 1, 2, 3. This is an integer array. We'll convert it to an integer variable and we'll have this 1, 2, 3. Okay. Then we'll add the 1 in that integer answer. We'll have 1, 2, 4. That is 124, and convert it back into an array. Okay. So it will be 1, comma 2, comma 4, and return this answer. So why I'm saying this is a brute force? Because we are converting the array of digits into actual number. But since we have the constraint, see the constraint digits dot length can go up till 100. But if even if we are not using the integer data type, if we are using the long data type, then also see the minimum and maximum value number of digits can be what? The maximum value number of digits can be what? 3, 36, 39, 312, 315 plus 318 plus 19. It can support up till 19 digits only. And in the constraint, we can go up till 100. That's why this brute force, I'm calling this solution as the brute force, and this will fail. It will have the integer overflow. Okay, now this is done. Like we are not going to implement the brute force solution. If you want me to implement the brute force solution, I'll upgrade it to another video. Then you please comment in the comment box like you want the brute force solution. I'll make another video for that. But now let's see the optimal solution. Okay, what the optimal solution will be? Optimal solution will be like 1, 2, 3. We will start from the least significant digit, and starting carry will be equals to what? Carry will be equals to 1. Carry will be equals to 1. So we'll add it, and this number will be what? This number, this specific number will be, first of all, we'll have one sum variable, sum equals to digits of I, whatever the digit is there. Okay, and digits of I plus carry. Then this number will be sum modulus 10. Sum modulus 10. And carry will be equals to the next carry. It will be sum divided by 10. So here this number will be what? 3 plus 1, sum will be 4. So 4 modulus 10 will be 4. And carry will be what? 4 divided by 10 will be 0. So carry will be 0. So it will be 124. Okay. Now see, whenever the carry becomes 0, the remaining digits will not change because there is no carry coming to that place. So they will remain as it is. So you have to break out from the loop whenever the carry becomes 0. Or if the carry is not becoming 0, which will happen only in the case of like this 9, 9, 9 plus 1. 9 plus 1, 10, carry 1. 9 plus 1, 10, carry 1. 9 plus 1, 10, carry is 1. So here 0, 0, 0 is there, and here carry 1 should be there. So in this case, what we have to do is we have to allocate another array of the size of the digits length plus 1, and all the digits will be 0, 0, 0, because if any would have been less than 9, any digit would have been less than 9. Let's say 8 is there, 9, 8, 9, and plus 1 I'm doing. So 9 plus 1 10, carry is 1, 8 plus 1 9. Okay. Now see, the carry becomes 0, so whatever the remaining digits to the left, they will remain as 9 and 0. So here no carry will be there. No carry will be there. Okay. Carry will be 0. So if the carry is not becoming 0 till the end, then we have this case. We have discussed this in the dry run. Now we will implement this optimal solution. Okay. Now I'm going to implement this optimal solution. What I will do is I'll say int I equals to digits dot length minus 1, because we are this I is pointing to the least significant bit. So it will be digits dot length minus 1. Okay. And carry. And since we want to add 1, so we'll take the carry is equals to 1. So we'll run this loop while carry is not equal to 0 and I should be also in the bound of the array. I is greater than equal to 0. So as discussed in the dry run, sum equals to digits of I plus carry. Okay. Then digits of I equals to, we'll update that value, digits of I. Digits of I will be equal to sum of modulus 10 and carry equals to sum divided by 10. Okay. Now see, if the carry is becoming 0, if carry equal to 0, then this loop will break because 0 not equals to 0 is false. And if carry is equals to 0, that means we have incremented all the values to the right of that breaking point, and the left positions in the digits. See this one. We have incremented till here. I mean till 3. 3 plus 1 4, and carry is 0. So no changes required to be done from the left to the carry equal to 0. So 1 2 will remain as it is. Okay. So we'll return the digits. There is no problem. Okay. Now coming here, if we are coming at this place, then what is the problem? See, carry is not equal to 0 and I is greater than equal to 0. So if we are at this place, then that means carry is not equal to 0. Then this loop would have been broken by this. I would not have been greater than equal to 0. I would have been minus 1. That means this all is exhausted. This all the is exhausted, like here 9, all would have been 9 in that case. So this is the case, because I is not greater than equal to 0. That means now we have this case. So here what is the thing? Digits dot length all are 0, and the first one is carry, whatever the carry is. Okay, and in this case it will be specifically 1 only. It will not be greater than 1, because if we are doing it maximum times 999, then only we are getting 1. So how it will go more than 1. Okay. So now what we'll do is we'll have this answer equals to new int 1 plus 1 plus digits dot length. Now what will happen? The array will be created of the length digits dot length plus 1, and all these values in Java, they will be assigned as the value 0. So we only need to change it at the 0 place. So answer of 0 equals to carry. Okay. Hmm? Answer of 0 equals to carry and return answer. And one more case is this, not the case. Since we are in a while loop, we are updating the carry, we have to update the I as well. So I minus minus. Now let me run this and see if it is passing the sample test cases or not. Yeah, it's passing the sample test cases. Now let me submit and check whether it's working fine or not. Yeah, so this is getting accepted. So now let's discuss the time complexity and space complexity. See, the time complexity is in the worst case, it can traverse all the digits dot n. So it is big O of n. And space complexity is big O of 1 because, see, nowhere we are using an extra array. The only extra array used is as to return the answer. So the array space which is there to output the answer or return the answer is not counted as an auxiliary extra space. That's why extra space is big O of 1 and time complexity is big O of n. So that's it for the problem. So yeah. So if you are seriously liking my videos, please do comment and subscribe to my channel. Yeah.